Okay, we've got one last topic to talk about here with continuity. And if we can add one value to a function that would turn it into a continuous function, it's called a continuous extension. And sometimes we want to find that continuous extension. So number one here says define f of 4 that extends f of x squared minus 16 over x minus 4 to be continuous at x equals 4. Okay, so we know right now it's not continuous because it's not defined there. So basically what we're doing is we want to make this piecewise function where we have x squared minus 16 over x minus 4 if x is not equal to 4. And then we're going to put in a number right here for when x equals 4 so that this is a nice smooth graph if you graph it. Well, let's think about what's happening. So if we look at f of x, sorry, I should really call this like a new function g of x, our continuous extension. Okay, so f of x here is x squared minus 16, which can be factored as x minus 4 and x plus 4 over x minus 4. And if you remember from pre-calculus that when we have the same factor in the numerator and the denominator, that creates a hole. So this right here is creating a hole at x equals 4. Otherwise, this function is graphing as x plus 4, which would be the line that has y-intercept 4 and slope 1. Okay, now what's happening at 4? We can see what would be at 4, but is a hole here. If we plugged in 4, we would get 8. So we've got a hole at y equals 8, but otherwise the graph looks like that. So what do we want to let it be? If we let this be 8, then we would be filling in that hole. Okay, so by figuring out where that hole would be, we can define a new function that at that value we say let that y value be whatever would fill in the hole. Okay, we're going to look at one more example here. It says find the constant b that makes h of x continuous for all real numbers. Okay, so for values less than 4, it's going to be x squared minus b squared. So we're going to plug a number in there. That'll be a polynomial. It'll be continuous everywhere. And then for bigger than or equal to 4, we're going to have bx plus 20, and b will be some number, so that'll be a polynomial. It'll be continuous. So what we have to worry about here is where it's changing. We have to worry about what's happening at 4. So we could say that the left-handed limit of h of x happens when we plug in 4 to the top here. We would get x squared, or sorry, we're plugging in 4 for x. So we'd have 16 minus b squared. And the right-handed limit and the function value here would be 4b plus 20. So this would be f of 4 and the right-handed limit. Now, for a function to be continuous, the limit has to exist, which means the right-handed limit, left-handed limit have to be equal. So we need to set these two things equal to each other. So 16 minus b squared equals 4b plus 20. Okay, let's move everything over to the right side. So if we subtract 16 and add b squared to both sides, we get 0 equals b squared plus 4b plus 4. And if we think about factoring that, that factors as b plus 2 times b plus 2, or b plus 2 squared. So we would set that factor equal to 0, and we'd get b equals negative 2. Okay, so that would be the function that makes it continuous, or that would be the number that makes it continuous for all values.